Here we are going to study one example of elastic collisions. There are two balls on a frictionless surface. No energy is lost on the friction. One ball has got mass m1, another m2, and they are moving in a straight line. Okay. In such a way that velocity u1 of the first ball is more than velocity u2 of the second ball. Therefore, it is approaching it. So this distance is covered by relative velocity and it goes near, both are moving and finally it hits it. When it is hitting it, that is known as collision. Now when it hits it, the energy is also transferred because of the push and its velocity increase. Its velocity increase, this velocity decrease. So the velocity after collision become v1 for this one and v2 for the second one. And in this case, we find that this goes with a higher speed and v2 is greater than v1 and they separate out. This is what happens. This is what happens actually. Okay. Now, in this, we know the quantities. Their masses are m1 and m2. We know the quantities. Their initial velocities are u1 and u2. But we want to find out what will be their velocities after the collision, depending upon their masses and these velocities. So we have to find out relations. What is our primary target? To find out the velocities after collision. Okay, these are the given quantities and this is what we want to find out. So we start our calculation. The rules of physics tells us that if it is an elastic collision, number one, momentum is conserved, and number two, the kinetic energy of the system is also conserved. These two give us two equations. What is the first equation we get is the momentum before collision is equal to momentum after collision. This is momentum before collision. And how much is momentum after collision? m1 v1 plus m2 v2, because we have to take momentum of the complete system, not the momentum of one body. This is complete system. And these two momentum before, after, they are equal. This is the one equation we get, and we can a little do the transposition so that m1 quantities are on one side, m2 quantities are on the other side. So this leads to m1 v1 minus u1. Bring it here, and this we go here. So this becomes m2 is equal to m2 u2 minus v2. Okay, this way, or we can make it plus minus whatever it is. In that case, this will be m1 u1 minus m1 v1. So this will be m1 u1 minus v1, and this will be m2 v2 minus u2. Okay, mathematically that does not make any difference. Okay, this is our equation 1. For kinetic energy conservation, KE conservation gives us formula. Kinetic energy before collision is equal to kinetic energy after collision, and that gives us before collision half m1 u1 square plus half m2 u2 square. This is kinetic energy before collision. And how much is kinetic energy after collision? Half m1 v1 square plus half m2 v2 square. This is after collision. Okay. Now, from this, we can again simplify this. Number one, half is cancelled from both the sides. Okay, it's a common. Okay, then m1 u1 square, take the quantity of m1 on one side, so this will be m1 u1 square minus v1 square is equal to m2 v2 square minus here u2. v2 square minus u2 square. This is what we get, and this leads to, this can be derived into two factors. This is m1 v1 minus u1, no, u1 minus v1 into u1 plus v1. This is equal to m2, and here again we have two factors. This will be v2 minus u2, v2 plus u2, v2 minus u2, and here v2 plus u2. Okay, this is, or this equation second converted to this. Now let's mark it 3. Divide equation number 3 with equation number 1. Okay, when we divide it, then m1 left hand side with left hand side. m1 is cancelled, u1 minus v1, this is cancelled. What we get here is u1 plus v1 is equal to this m2 v2 minus u2 is cancelled out, and what we get here is v2 plus u2. And this gives us a very famous relation, that is, it's leading to u1 minus u2 is equal to v2 minus v1. What is this? u1 minus u2. u1 minus u2. This is the relative speed between the two. That is the speed with which this object is reaching this object. So closing this object. So this we will write as velocity of approach. Which one? This one. This is u1 minus u2 is velocity of approach. They are approaching each other. And v2 minus v1, v2 is faster, v1 is slow, so they are separating out with relative velocity v2 minus v1. So this is v2 minus v1 is given the name velocity of separation. This. So velocity of approach is equal to velocity of separation. This is a very important conclusion of elastic collision. You have seen when we throw a ball to the ground, and if it is elastic collision, velocity of approach to the ground is equal to velocity of separation. That's why it reaches to the same position. This happens in elastic collision, and we must remember this. Velocity of approach, velocity of separation, and they are equal to each other. Now, once we have got this equation number 4, there are 1, 2, 3, 4 quantities. These two are known quantities. These are two unknown quantities. If there are two unknown quantities, we need two equations to find out their value. So we use this as one equation, and we use this as second equation. So by using equation 4 and 1, by using equation 4 and 1, this part. Okay, from here, if we want to find out velocity v1, then what do? We find v2 value from this equation, put this value here. So we get only one unknown v1, and we can always find out. Okay, so what is v2 here equal to? v2 here is equal to u1 minus u2 plus v1. This is from 4. We put it here. If we put it here, what do we get? m1 u1 plus m2 u2 is equal to m1 v1 plus m2, and in place of v2 we are going to write this whole thing, u1 minus u2 plus v1. This is, open it up, so this will be m1 u1 plus m2 u2 is equal to m1 v1 plus m2 u1 minus m2 u2 plus m2 v1. Yes. Okay. Now we want to find out what is v1. So in this we separate out the terms of v1 on one side. So v1 is here, v1 is here, nowhere else. These two we transfer on this side. Okay. Now these two, when we transfer on this side, what do we get? m1 u1. First we write this on the left hand side. This is m1 v1 plus m2 v1. Take out common v1, and what we get here, m1 plus m2. m1 plus m2. This is equal to, here, m1 u1 plus m2 u1. Then m2 u2 plus m2 u2. This is. So how much is v1 equal to? v1 is equal to, here take out u1 as common, m1 plus m2 into u1 divided by m1 plus m2. Okay, there is a mistake here, m1 u1 m2 u1. When we take it on this side, then this will be m1 u1 minus m2 u1. m1 u1 minus m2 u1 minus. So when we take out u1 common, this will be m1 minus m2 u1 plus 2 m2 2 m2 into u2. Now this m1 plus m2 will go here as denominator, m1 plus m2. Here also m1 plus m2. This. So this is velocity of the first ball. This is u1, u2. The masses m1 minus m2, m1 plus m2. Here 2m2 and m1 plus m2. This is velocity for ball number 1. What will be the velocity for ball number 2? That we can get if here we find out the value of v1 and place it here, and we will get there are changes in this. That also we can find out. First I will write it in the corner and then we will change it. So this is velocity 1. Now we will try to find out what is the velocity of the second ball, and for that we will start from here itself. To find out velocity of the second ball, v2. From here we find out what is v1 equal to. Take v1 on this side, so v1 is equal to v2. This will be minus u1, this will be plus u2. This is velocity v1. Now this value we are going to put in equation 1 in place of v1. So we rewrite this, and this will become equation 1. m1 u1 plus m2 u2 is equal to m1 v1 m1, and in place of v1 we write this v2 minus u1 plus u2. Okay, then plus m2 v2 plus m2 v2. Now open it up. So this will be m1 u1 plus m2 u2 is equal to m1 v2 minus m1 u1 plus m1 u2 plus m2 v2. Okay, we got it simplified. Now we have to find out the value of v2. So all v2 terms are taken on one side. So this is m2 v2 and here m1 v2 plus m1 v2. This is on one side. On the other side we get here is m1 u1 plus m2 u2, and this is done. This will become plus m1 u1 and this will become minus m1 u2. So we have it here, v2 common, and there is m1 plus m2, m2 plus m1 is equal to, here what do we have is this is same and these are having common u2. So this we can write as m2 minus m1 into u2 plus 2 m1 u1. So what is value of v2? This leads to v2 is equal to m2 minus m1 upon m2 plus m1 into u2 plus 2 m1 upon m2 plus m1, because this will be denominator of both. This will go on this side, denominator of this as well as denominator of this, into u1. This is v2, so I write it here. v2 is equal to m1 minus m2 minus m1 upon m2 plus m1. This whole thing is to be multiplied with u2 plus 2 m1 divided by m2 plus m1, and this whole thing is to be multiplied with u1. This is velocity for ball number 2. So these are the two results we get here. If you see these two results simply, you have to remember only one result. The result number 2, you will find replace m1 with m2 and u1 with u2. See, m1 with m2 and m2 m1, m1 m2, m2 m1. So all m1 and m2 are to be interchanged and u1 and u2 are to be interchanged. u1 will become u2, u2 will become u1. So please remember, if you remember only one, that is sufficient, because in the second one you have to interchange and you will get, that is velocity for ball number 1, velocity for ball number 2. This is the conclusion of the elastic collision. So now we have got two things. Number 1, the velocity of approach is equal to velocity of separation. This is one conclusion, and this is other calculation of velocities. Now, based on these two conclusions, there are certain special cases which are more important than this calculation, and that we have to understand. That we will do in the next question. Thank you.